We are going to see difference of two mean test type 2. So here problem based on the means x1 bar and x2 bar known and population mean also known, mu1 and mu2. The previous case only sample means are known, population mean we don't know, right? So this is the second type. We will see the test procedures and the formulas. So test procedure, step 1, to find the value of z, that is calculated value. Test statistics, z is equal to, so both are known, right? x1 bar minus x2 bar minus mu1 minus mu2 divided by root of sigma 1 square by n1 plus sigma 2 square by n2. So here we know sigma 1 sigma 2 population mean, standard deviation, right? n1 and small n1 n2 is the sample sizes, right? Suppose we know population standard deviation, then we have to use the first formula. Otherwise, instead of sigma 1 sigma 2 we have to use the sample standard deviation s1 s2. So formula will be x1 bar minus x2 bar minus mu1 minus mu2 by root of s1 square by n1 plus s2 square by n2. So next, defining hypothesis, we know the standard result for two tile, then right tile, then left tile. So table value is same, right, like previous. Step 3, automatically conclusion. So calculated tabulated, we are comparing the calculated value and tabulated value. Calculated is less than, always it should be less than tabulated. The right and two tile. Left tile test, if you are taking the negative value, it will be reverse, right? Calculated is greater than tabulated value, because if it is a negative, so maximum you take the modulus value, right? If you are having the negative value in the right tile or two tile, take the modulus value, then compare the tabulated value, right? So confidence interval formula, x1 bar minus x2 bar plus or minus z alpha root of sigma 1 square by n1 plus sigma 2 square by n2. If you know sigma 1 and sigma 2. So if you know s1 and s2, so formula will be x1 bar minus x2 bar plus or minus, just replace, that's all, z alpha into root of, replace sigma 1 sigma 2 by s1 and s2, s1 square by n1 plus s2 square by n2. So standard error SC or E, which is equal to root of sigma 1 square by n1 plus sigma 2 square by n2. If you know sigma 1 and sigma 2. If you know s1 and s2, standard error which is equal to root of s1 square by n1 plus s2 square by n2. Next, we will see the problem. The electric light tubes of manufacturer A have a lifetime of 1400 hours with a standard deviation 200 hours, while of manufacturer B have a mean lifetime of 1200 hours with standard deviation of 100 hours. If random sample of 125 tubes of each batch are tested, what is the probability that the brand A tubes will have mean time which is at least, first question, 160 hours more than the brand B tubes, and second question, 250 hours more than the brand B tubes. So electric manufacturer lifetime is the mean, right? He is taking sample from each brand A, brand B, brand A and brand B. So he is taking the equal sample size. So n1 equal to 125, n2 equal to 125. Here lifetime, mean lifetime, that is x1 bar and x2 bar, right? Instead of x1 bar and x2 bar, so they have given electric light tube manufacturer A have a lifetime. First they have given the lifetime of the whole population, right? They have not mentioned anything like sample, right? So that is mu1 equal to 1400 and sigma 1 equal to 200. The second case also mean lifetime, mu2 is equal to 1200 and standard deviation is 100. Then he is coming to the sample, right? If random sample of 125 tubes. Next only is coming. So first they have given population, mean population standard deviation, right? So x1 bar, x2 bar, you assume that a sample mean of brand A and B. To find the probability that brand A will have a mean time at least 106 hours more than the brand B. So here to find first brand A x1 bar, which is greater than or equal to more than, at least more than, right? At least x2 bar plus 160, right? So probability of x1 bar greater than 160 plus x2 bar, which is equal to, taking that x2 bar to the left hand side of the inequality, you will get a probability of x1 bar minus x2 bar greater than 160. Now you subtract mu1 minus mu2 on both sides and simultaneously divide both sides by root of sigma 1 square by n1 plus sigma 2 square by n2. So you will get x1 bar minus x2 bar minus mu1 minus mu2, which is greater than 160 minus mu1 minus mu2, right? First step. Second step, divide both sides by root of sigma 1 square by n1 plus sigma 2 square by n2, which is greater than 160 minus mu1 minus mu2 by root of sigma 1 square by n1 plus sigma 2 square by n2. We know test statistics, z is equal to x1 bar minus x2 bar minus mu1 minus mu2 by root of sigma 1 square by n1 plus sigma 2 square by n2. So using this, so you will get so we know everything, values mu1 minus mu2, you can substitute directly in that formula, right? Otherwise you calculate separately and substitute that. So 2, 3, 4 you are using in 1. So this is equal to probability of z greater than 160 minus 200 by 20. So probability of z greater than minus 2. So this is 0, this is minus 2. Greater than means this side, right? Because negative, right? This is the area, normal area. So normal curve area greater than minus 2, this is total area, right? Greater than minus 2, yellow shaded area, right? So now the right side of z is equal to 0 line, the total area is 0.5 we know, and the left side is also 0.5. So total area of the normal curve 1. So left side to z is equal to 0 because symmetrical, right? That is why this is this one 0.5 and right side 0.5. So normal curve area right side plus normal curve area between z is equal to 0 to z is equal to minus 2. So z is greater than minus 2 can be splitted into 2. So minus 2 to 0, that area, right? Minus 2 to z is equal to minus 2 to z is equal to 0, that area, plus right side area, that is 0.5. So 0.5 plus normal curve area between z is equal to 0 to z is equal to minus 2. So 0.5 plus probability of minus 2 less than z less than 0. So this can be written as 0.5 plus probability of 0 less than z less than 2, because minus 2 to 0, that is area. Probability is nothing but area, normal area, right? Don't get confused, right? So minus 2 to 0 area is nothing but, area is always positive, is nothing but 0 to 2, because symmetric, this side area is equal to that side area. So minus 2 to 0, minus 1 to 0, minus 3 to 0, all are equal to 0 to 1, 0 to 2, 0 to 3, like right side. So that is what we are replacing, which is equal to 0.5 plus probability of 0 less than z less than 2. So from the table 0.5 plus 0.4772, that is equal to 0.9772, right? So next, to find the probability that brand A will have a mean time at least 250 hours more than B. So instead of 160 we are going to use 250 here, same problem, right? So same procedure, you proceed like that, then you substitute the values, right? Same idea only. But here you are getting probability of z is greater than 2.5. So z is equal to 0, z is equal to 2.5, greater than means, right, yellow shaded. So right side area 0.5, left side area 0.5. So yellow shaded area can be written as, so total left right side area 0.5 minus z is equal to 0 to z is equal to 2.5. You have to remove that one, you will get the remaining area, right? So greater than 2.5, so right side area minus area between 0 to 2.5. So 0.5 minus probability of 0 less than z less than 2.5. From the table 0.5 minus 0.4938. So you will get 0.0062. Thanks.